Corporate finance practice problem using Excel. Zero coupon bond, effective yield to maturity calculation. Get ready. It's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we are in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. Information on the left-hand side will populate that into the blue area on the right-hand side. We're going to be calculating the effective yield to maturity for a zero coupon bond. Now, note that's going to be the change here that we have this zero coupon bond. For normal bonds that are not zero coupon bonds, we focused in on that in a lot more detail in a prior section, so you can go back there and take a look at that in more depth if you want to see that a little bit slower and in more depth. If you're looking at these bond calculations, primarily focusing in on time value of money calculations, present value calculations, future value calculations, you might want to take a look at a prior section where we focus in on that in detail, where we will do this not just in Excel, but also with formulas and with tables. So here we have the adjustment, the difference here being the zero coupon bond. So our information is it matures, the maturity amount, basically the face amount of the bond you could think about as the 1,000. The sales price, the current price, then the 550. Years to maturity are going to be 10. There's no rate on the bond because it's a zero coupon bond. We are in essence looking at the market rate or the effective yield to maturity rate. That's what we're going to be looking for. Now, this should be easier than it would actually be for a normal bond, because normally when you're calculating, say, the sales price, you would typically, if you had like the market rate, you would typically need to be adding up the present value of the annuity, of the interest payments, and the present value of the maturity values, adding them up in order to get the price. This time, we don't have the annuity component because there's no interest payment. So we only need to be dealing with kind of like the present value of the maturity values. So therefore, you have a couple different options that you could approach this type of problem at. So you could use the future value formula or the present value formula. So for example, if you're say you're starting at the present value of the 550, you're looking at the effective yield to maturity to get you to the future value of that 1,000. You could do that mathematically with the formula of future value equals the present value times 1 plus r to the n. And then you could plug in your numbers there. And I won't do the algebra here, but you could plug in the numbers and it would look something like this. 1,000 equals the 550. So 1,000 is the future value, equals the 550, the current price. And then 1 plus r is what we're looking for. That's the effective yield to maturity to the number of periods, which is 10. That's one method you can look at it in. Or you can also say, well, the present value formula, I can plug it in there and say, well, the present value, which is the 550, would equal the future value of the 1,000 times 1 over 1 plus r. That's the unknown to the number of periods n. So you can kind of you can look at it either way, and it's useful to kind of be able to see it either way. I won't do it algebraically here. We'll do it with a goal-seek kind of function, and then we'll use the rate function to calculate it as well. And then we'll do the present value looking at it at this side. So if I think about the same formula in terms of an Excel function, and I say, okay, I'd like to use that kind of algebraic method solving for that unknown, that r right there, but I'm using a function, so I can't rewrite it algebraically. We could use another function, which would be the rate function, but I think it's more intuitive actually to use the future value function, and then we'll use the goal seek feature to find that unknown. And a really, really useful thing to do with any function that you use in Excel, to be aware of the goal seek and how you can kind of utilize that to find an unknown rather than the end result, in this case, the future value. So what we'll do is we'll just plug in a number, 10%, and then I'll put in this future value type of calculation as a function in Excel, which would be looking like this. Negative future value, shift 9. The rate we're going to take is that 10%, and then we'll change that later so that we can ask Excel to change it to what it needs to be to get the end result to what we know it should be, which is $1,000. So then comma, number of periods is going to be 10, comma, comma, because it's not an annuity but present value of 1, picking up then that $1,000. Sorry, this is the present value, the $550. Closing this up, that's going to give us the 1,427. Now we want to change this 10% to whatever it needs to be to get that 1,427 to equal $1,000. So we could do that by changing it manually to 8%, for example, and so on until we get there. Or we can ask Excel to do that with Goal Seek. So we can go to the Data tab up top, Forecast, What If Analysis, Goal Seek. We're going to seek the goal. What is the goal that you seek? We seek the goal of that thing right there to be equal to, we got to hard code or type in this number. That's what hard code means, by changing the 7% rate. And then we're just going to say OK. And Excel then changes that rate to 16.16, what it needs to be in order for the future value to be the 1,000. That then is going to be our effective yield to maturity. Now, we could actually use a whole different function to do it. That would be the rate function. So we could do the rate function to kind of figure that out. If you do use the rate function, I would still do a calculation such as this one to kind of double check your work, this one or the present value, which we'll do shortly. So the rate would be something like this. We're going to say this equals the rate, and the rate function, shift 9, the number of periods is going to be 10. The payment is going to be 0. We don't have any payments because we don't have that annuity component. So I'm just going to say comma, comma, or you could put a 0 in there if you would like. The present value, I believe, has to be negative. Actually, I don't know, not the present value. The present value is a 550, not negative, comma, and I think the future value then needs to be the one that's negative. That negative kind of throws things off there. So we're going to take the future value and then comma, and then we're going to pick up 0, which is the end of the period for that component, and enter. So there we have the 616 again. So here's your calculation once again there. Okay, so now you can also think of it in terms of the present value formula, right? I could say, well, the present value would be equal to the 550 equals the future value, which is the 1,000 times 1 over 1 plus r, the unknown, to the number of periods n. And I can basically do my same goal seek procedure there. So let's pretend that's the way we think of it. We're going to think maybe your thought process is more geared towards the present value side of things. And we're going to say, all right, what if I used Excel to do the same kind of process with the present value formula and then used our goal seek to put this rate to whatever it needs to be? We can say, all right, negative present value calculation. The rate is going to be that 10%, which we will change later with the goal seek function, comma. Number of periods is going to be 10. 10 on the periods, comma, comma, because it's not an annuity, but present value of 1. Now we're going to pick up the future value, which we know is the 1,000, and enter. We get the 386. We need that to be the 550. We're going to ask Excel to change this 10% to whatever it needs to be to get the end result where we want it, the 550. We could start to do that manually, of course. We could say, well, what if this was 7%, and so on. We get pretty close. Now let's ask Excel to do it. We're going to say Excel, Data tab up top, Forecast, What If Analysis. We have another goal that we would like you to seek. And what's the goal? We want to set that cell right there, the present value, to be what we know it should be, 550. 550 by changing the rate cell involved, the 7%. So then we're going to say OK. And then it does it again. There we get back to that 16.16%. So you can kind of think about this one a few different ways. It should actually be an easier calculation, but if you could see it in different formats, any of these kind of calculations, you're getting an idea of the relationship between the present value and the future value formulas, how they can work in a function, how you can use the goal seek for it, and of course how the rate formula can work in relation to them as well. You just get a better understanding, so that when you see other people calculating these things, they might use different methods. They might use the present value, you're using the future value. They might use goal seek, they might use the rate formula. So the more you kind of can tie all that together, the more you'll be able to understand and work with other people as they're doing things differently or as they see things differently.